Okay, what I want to do now is go through and just take you through some examples, show you how to use the periodic table to write these formulas. So let's just start with the one that we looked at. So if we write what happens with sodium and how it forms an ion, so we have sodium, so this would be a neutral sodium atom. And sodium as a metal, when it reacts, will lose an electron. And this is how we represent the losing of an electron. Now chlorine is a gas and it's a nonmetal and it's also diatomic. So with chlorine it's going to look like this. And each chlorine atom gains an electron. Because there are two chlorine atoms, then that's going to be gaining 2 electrons. And so over here we'll have this. At this point what happens is the chlorine and the sodium are attracted to each other. So the sodium we call a cation because it has a positive charge, and the chlorine has a negative charge. So we have this situation. This is called Coulombic attraction. It's just the attraction because there are different charges. So if we look at what we have when we have, a substantial amount of sodium chloride, it's not an individual molecule, and that's a very important point for us. So what we have is this array. So we have sodium, chlorine alternating. This is kind of an expanded view here, and over here we have the space-filling view. There are a couple of other things I want to point out while we're here. One is that the sodium ion is smaller and the chlorine ion is larger. The idea here is that the sodium has lost an electron, and that's going to make it smaller, and the chlorine has gained. And also you look at how they're packed together, they make this cube. If you were to take some salt and look at it under a microscope, actually if it were some salt that you made by taking some salt water and evaporating it, and then let the little salt crystals form, what you would see are little cubes, much bigger than this, but in other words, as the crystal grows, it becomes larger and larger and keeps this same shape. Okay, so go back to where we were here. So this is sodium chloride. Now we don't put the plus and the minus charge there, so we don't, that's not included, so we would just write NaCl like this. But the principle that we use to write this formula is that they are held together, these two ions are held together by the difference in charge. Let's look at another example. So if we take a look at the periodic table, we'll see that, let me pull the periodic table up. All right. So in the previous video, I pointed out that if elements are in the same column, they have similar properties. And you'll notice over here these little numbers that are under the name of the element. So lithium 1, sodium 1, potassium 1, rubidium 1, and so forth. In the second column, you will see, not counting helium, but you'll see 2, 2, 2. Over in this section, you'll see the electron configuration. So some of you are going to know about this because of what you did in middle school. But for the moment, we'll just leave that. That's not really important to our discussion right now, although the charges that atoms get have to do with their electron configuration. But we'll get back to that a little bit later. So for now, let's just see how we can use the periodic table to help us write the formula of something that we don't know. So let's say that we are trying to write the formula for lithium bromide. So if we look at lithium, lithium is in the first column, and it has this 1 there, which tells us its oxidation number. That's the number that it will have once it's lost an electron, so that's 1. And if we look over here, and we look at bromine, we see that bromine can in fact do a variety of things, but for our purposes right now, we're only going to consider the fact that bromine can gain an electron. All right, so if we go back to the situation here, so let's just write down what we know at this point. So at this point, we have potassium, and we know that potassium reacts very similarly to sodium. So potassium will lose an electron, and we know that bromine is diatomic, and each bromine atom will gain an electron, so Br2 will gain 2 electrons. So over on this side we'll have oops, not that. We'll have 2 Br minus ions. And then we'll have this attraction between the two, like this. And so that's the correct formula for potassium bromide. So let's try something a little bit different. So we have the periodic table again. Let's do something where we pick an element from the second column. So let's pick calcium. And let's try to figure out what sort of compound would form when calcium reacts with iodine, which is over here. So if we look at calcium, we see that it's in the second column, and its charge that it gets after it loses electrons, or let me just go ahead and call that its oxidation number, 2. And then over here, we see iodine. Iodine can do several things, and this is one aspect that we're going of elements that we're going to have to deal with, is that they don't always lose or gain the same number of electrons. They vary some depending on what they react with. But again, for the moment, let's just assume that we're dealing with the situation where iodine gains an electron, and we're going to write the formula for calcium iodide. So if we go back over here, and so we'll kind of skip ahead just a little bit, do this faster. So we've got calcium, and calcium will tend to lose 2 electrons, so it's going to have a +2 charge, and iodine will tend to gain an electron, so it's going to have a negative charge. Now the principle is that we want these to balance. We want the sum of the positive charges to equal the sum of the negative charges. So in order to do that, we put a 2 here, and what this means is now we have 2 iodines, and each of them has a -1 charge for a total of -2, and the calcium has a +2. Well, what if we were trying to do the formula for barium oxide? So I'm not going to go back to the periodic table, but if you look at it, you'll see that barium is in the same column as calcium, and oxygen is 1 over from iodine, so it's in column 16. And everything in column 16 has a -2 charge. So if we look at that, Ba, which is +2, and O, which is -2, balance, so that's it. That's the formula, so BaO. What about if we were looking at aluminum? So aluminum is in column 13, and it has a +3. And let's do sulfide. So sulfide is in the same column as oxygen, and it has a -2. Well, in this case, we're going to have to multiply both of the elements by some number to get what you could call the lowest common factor or lowest common multiple. Maybe that's what that's called. Anyway, so one way sometimes people think about it is that you crisscross these. So you'd need 2 aluminums, and you'd need 3 of the sulfur. And let me just show that a little bit up here as well. So we have that, and we have that. Now we don't write this out. This is not part of the formula. I'm just writing this to explain to you. So what we write is just this. And for the name, we just say the first name as it is, aluminum, and then the second name, we just say the name, but we drop the ending. So instead of sulfur, we say sulfide. So this one is called sulfide. All right, well, even now, when we haven't gone so far, you are able to use the periodic table, and you could write hundreds, if not thousands, of correct formulas just based on these simple rules. So that's a good start. In the next video, we'll take a look at what happens when we have a situation where the cation can have more than one charge, and how we indicate the particular charge that it has.